In this video we will discuss about an emission nebula in detail. The emission nebula is a type of nebula that is formed of ionized gases and emits light of various wavelengths. The most frequent cause of this ionization is high-energy ultraviolet photons released from a nearby hot stars. Types of emission nebulae. Their first one is HII regions and second one is planetary nebula. The first one is H2 regions. H2 regions are the most common type of emission nebula, where massive, hot, young stars, O and B stars, ionize the surrounding hydrogen gas. The ionized hydrogen emits a characteristic red light, making these nebulae appear red or pink. The second one is planetary nebula. These are formed when a dying star, nearing the end of its life, sheds its outer layers. The exposed hot core of the star then ionizes the ejected gas, creating a glowing nebula. The colors in planetary nebulae can be more diverse, including blue and green, due to the ionization of elements like helium and oxygen. Source of ionization and brightness of the nebula. The primary source of ionization, which excites the gas and makes it glow, is the ultraviolet radiation emitted by hot, massive stars within or near the nebula. This radiation strips electrons from hydrogen atoms, and when these electrons recombine with the atoms, they release energy as visible light, creating the nebula's characteristic glow. The brightness and color of an emission nebula are determined by several factors. Stars' luminosity and distance. The intensity of the ionizing radiation from the central stars directly impacts the nebula's brightness. More luminous and closer stars will produce brighter nebulae. Gas composition. While hydrogen is the most abundant element in most nebulae, other elements like oxygen and nitrogen can also be ionized and contribute to the overall color. For example, ionized oxygen produces a green hue, and ionized nitrogen can produce a red or orange hue, but the characteristic red color of many nebulae is due to the hydrogen emission. Density and size. The density and size of the nebula also play a role. Denser regions will have more atoms available for ionization and recombination, resulting in brighter emission. Presence of dark areas in emission nebula. Dark areas within an emission nebula are caused by obscuring dust clouds. These clouds, composed of submicrometer-sized dust particles, effectively block visible light, creating the appearance of dark patches against the brighter emission nebula. Some emission nebulae, like the Trifid Nebula, even incorporate dark nebulae within their structure. Examples of emission nebula. Some prominent examples of emission nebulae visible from Earth include the North America Nebula, NGC 7000, and Veil Nebula, NGC 6960 or 6992, in the Northern Celestial Hemisphere, and in the Southern Celestial Hemisphere, the Lagoon Nebula, M8 or NGC 6523, the Orion Nebula, M42, and the Bright Carina Nebula, NGC 3372. You can think of an emission nebula like a giant, cosmic neon sign. Just as electrical energy excites gases in a neon tube to make them glow in specific colors, the intense ultraviolet light from hot, nearby stars, or a dying star's core, excites the gases within the nebula, causing them to emit their own light, with the specific colors depending on the types of gases present and how much energy is exciting them. Some nebulae can even exhibit characteristics of multiple types. For example, the Trifid Nebula contains regions of emission, reflection, and dark nebulae. By studying these different types of nebulae, astronomers gain valuable insights into the processes of star formation, stellar evolution, and the chemical enrichment of the universe. Thanks for watching. See you in the next video.